So let's get started. So welcome back, everyone. So today we're going to talk about privacy. So this I will eventually get into some techniques going to actually recommend. But uh, so this lecture will be a little bit kind of different in that I'm going to be aiming to give a lot of context and kind of the history, uh, the relatively short history of how we've thought about the intersection between privacy versus data analysis. Um, uh, and so why this is important and what you can do about it. And so the ultimate answer is you can kind of add noise to data to protect privacy, but how to do that, how to think about it, I'm hoping you'll have kind of a solid understanding of that by the end of the lecture, and some of the challenges of this as well. So this will hopefully also explain, a lot of you are working with a variety of data sets you found online, and there's sometimes some like strange properties of these data sets, right? You see these values which you think are continuous values, but like there are only a smaller number of these continuous values that all the attributes kind of so share. Why is that? So hopefully again this lecture will give some context into this. So and the big picture here is that we've been talking about data, right? So we have this data set X, right? And so you can maybe think of this data set as being kind of this row of these of this like matrix of values. We have usually n of the values, and then you can think of having the attributes. Okay, and we said, well, what did these represent? Could be data off some weather stations, or we were looking at kind of representations of word vectors embeddings. And so today I want to think about what if there's this data set xi, what if this was you? All right, so what if that row in the data set was represented your characteristics? Like, would you want this to be part of a big kind of data analysis study? Or when would you be okay with that, right? What if your information was up there? Okay, and so and I want to have you think about it as if it was your data, because it's really a question of kind of the ethics of data analysis. And I want to equate this to having uh, um, some form of like empathy. Okay, maybe it's not your data, but it's if these are representing people, then this data point is someone's data, and I want you to put in your shoes if you think this was your data. Okay, so we offer, I guess if you're most of the undergrads are taking a class in the ethics of data science, right? And you're thinking about these things. There's lots of ways to think about what should your ethical perspective be. When I taught that course, I tried not to have a point of view. In this case, I want to kind of have the point of view that you should try and be like empathetic, that if your data was in this situation, would you want this to be exposed for you, right? As like the perspective. Of course, there are other utilitarian perspectives. There's these things about, okay, should we be trying to get to an all-knowing, all-helpful AI as quickly as possible perspective, right? You could have these other perspectives in today's lecture, thinking about if your data was being analyzed. Well, in the context of this is I'm going to kind of relate this through some stories. And so in the in early 2000s, what was going on in the early 2000s in tech, right? There were these big kind of companies that now these are kind of the wealthiest, kind of the most, I guess they're the most valuable companies in the world, the Google, the like the Amazon, things like Yahoo, which is no longer the most valuable company in the world, but at some point was in the league. Microsoft, Facebook joined them. They were gathering lots of data. It was very exciting. We had much bigger data sets than we had ever had before on all sorts of topics. And these companies didn't know what to do with them. They were figuring out that having the data was useful for making better predictions. For Amazon, you could help you find a more diverse set of products that you couldn't get just at the store, or better recommendations for those products was so sometimes an objective. In Google, better search of the world's information. This all seemed good. What can we make sense of this? So data, and it was very early in this field that we're now so talking about today, and data mining, kind of machine learning, kind of fits into this. And so they would collect lots of data, usually on their customers. Okay, and often those customers were people. Okay, it's not always, and they didn't always know what was capable. It was quickly developing field, so they would make this data public sometimes. Okay, sometimes it would not be the whole data set, but they would take, here's an example data set that we have. Let's go put an example data set online and say, we would really like to be able to do this. They would say, we have much more data we're not going to share with you that we collect, but if you can transform it, understand it better, we can apply this on all sorts of other stuff. And instead of hiring a whole bunch of research teams, which they were also doing at the time, they went out and went to all the universities out there and said, hey, here's some cool data you've never seen before. Can you run your algorithms on? Can you develop some better algorithms? And this was quite common in the early 2000s. And even when I started teaching this class, the first few years I was teaching it, there would be more data sets every year or two, and then this stopped. Okay, a couple things why this stopped. Okay, in the late 2000s, the late aughts, kind of this stopped. Okay, and this, I think part of the story you'll hear is that they felt, well, they didn't want to give away like an advantage they have. But part of it now is that there was a concern about the privacy of the individuals. You could expose personal information about users. What if anyone could figure out your search history, right? So inside of Google, they know all of your search history. Well, maybe you've been not identified as who is the person whose search history this is, but most people have searched their own name, right? And so you can kind of make a pretty, I mean, has anyone not searched their own name inside Google? Okay, so everyone's searched their own name, so you probably have a pretty good guess of who the person is. I probably searched for my name as much as anyone else's name, so just to see what Google is thinking of me, right? So you can probably figure out from someone's search history who they are pretty reliably. Okay, and then they know everything else that you've searched for. So maybe this is okay. Maybe there's stuff you wouldn't like people to know. Okay, so there. So this stopped, and so what should we do about? What can we do about it? All right. So let me kind of, and this was not just the big sort of tech companies. Let me tell you another story. Okay, and okay, so this is with health records. You can imagine this being even more kind of like This could also be an issue. So let's see, in around 2000, I guess Massachusetts, the state of Massachusetts, where this is where MIT and Harvard and a bunch of universities are, I guess someone lobbied the government, convinced the state to release the medical records publicly of all the state employees. Okay, they said, if we put these all online, we'll be able to do research on them, we'll make all these medical advances, and the state got convinced to do this. Okay, they wiped all the IDs, right? So they didn't say, okay, this is this person's name, but this is their medical records after we've removed all their name. And so, but they kept geographic information about them. They kept things like, let's see, the zip code of the individual where they lived, their birthday, their gender. These were among the characteristics they had. Okay, but they said, well, we don't have the name, so we said this is anonymous. It'll be fine. People do science on it. It's going to be great. Okay. Okay, but at the same time, and this is often the case in many states, you could buy the voter data for the state of Massachusetts who voted in the last election. Okay, and that had the actual names, but also traits like the zip code and the gender of all the people who had voted in the state. Okay, so there was a then graduate student at the University of Massachusetts, LaTanya Sweeney, who went and said, well, I'm going to go grab both these data sets and try and figure out who is who, and felt that using the information on the gender, the birthday, and the zip code with the combination of this data was able to identify the governor of the state of Massachusetts. And the story is, I don't know if this is true, she mailed the medical records to the governor of the state of Massachusetts saying, you probably shouldn't keep doing this. So LaTanya Sweeney made kind of a career out of this. She now teaches at Harvard, kind of investigating these those sorts of issues, right? So the idea is, putting all this data online seems like great. I'm glad you all found data sets to work with online, but you have to be careful about public information. Okay, and that even if you anonymize it by removing the names and certain things, it doesn't necessarily prevent someone from figuring out whose data was whose. Okay, and so this is now something that we as a community pay much more attention to. So what came out of this, right? So the question is, given this, we still want to release data. So how do we, or let's say, how can we release data so anonymously while preserving some information. And so I want information so that enough information that we could do some data mining or machine learning or AI on top of the data and draw some interesting conclusions about it, right? So what do you think? How would we, what's the right way to do this? How could we release data? There's still data sets out there. All of you went and found data sets. Some of them found data sets related to health, right? You may have had to go through some training on this, but so how can we release data while preserving kind of information, but still have it be rich enough that we can still do analysis?
Could you possibly change the representation of some of the data you're using?
Okay, well, what do you mean by change the representation?
I can't think of a specific way, but just applying some sort of transformation. Have the data still give the same information if you were to analyze it, but from a first glance, it couldn't be traced back to anything.
Yeah. Oh. Yeah. Okay. let me say that what you're pointing at is kind of the goal here. We want to kind of represent the info so we can draw generalizations, right? So I want to make a scientific hypothesis, or I want to kind of make a scientific statement. I think there's a relationship between living next to a river and being able to swim really well. I don't know. So we need to know who lives next to a river, who knows how to swim. And I want to be able to draw that conclusion and maybe even convince other people that this conclusion is true. But I don't want to release individuals who live next to a river or not, right? So I want to be able to draw this generalization, right? I want to be able to find a pattern in the data that I think represents some interesting scientific hypothesis or even a conclusion without revealing the individual information. So if I change the representation, so I somehow want to change the representation so I can still do this. And the question is, what can we give? So one way, if I mapped into a feature space using techniques we learned about early in the semester, do this, but I don't have the raw data. Maybe I'm worried I would abstract it too much if I just mapped it into some high-dimensional learned representation. I'd want some individual characteristics so I could kind of verify all the steps of my method and conclusion, right? Yeah. All right. So I want to do something more low level than this. Okay, then be able to map it into a really abstract space, or just look at the final conclusion. I want to say, what is the initial step I can do to release some data that could be mapped into this without releasing private information?
I guess, like, in the case of the medical records, you deal with it by the governor's degree, if zip code, birthday, and whether
Gender, I think.
gender, right? So if you can make it so there's no unique combinations, right? At least 4 people or 5 people all have the same combination.
Great. So what you have described was the first bullet point I wanted to hit perfectly, called k-anonymity. Okay, this was kind of the first method proposed in this space. And what it says to do is to kind of remove kind of attributes. And maybe it was from a subset of the records until each kind of combination of like the attributes available maps to at least k different records. All right, so in your analysis, you said 4 or 5 people. So I'm gonna make sure I don't release enough of the attributes so that for each row there are at least 4 or k generally other rows that look exactly the same, right? So I can't say, well, this attribute is kind of this row, and there's at least k other rows. And usually when they talk about this, they usually divide data into kind of the so into kind of these public attributes and private like the private attributes. So the public attributes would be something like the like the zip code, kind of the age, the like like the gender, the so things like this, where the private attributes would be something like has cancer, has diabetes, kind of searched for what? So Britney Spears, right? You know, so some maybe embarrassing attributes to search for in Google. You can think of, okay, so usually you want to do analysis to learn something. The private attributes are the stuff you want to maybe draw scientific conclusions from, but that would generally not be publicly known. And the public attributes are things that you'd think, okay, these might be kind of in the public sphere. They might help me identify some person. Okay, and you want to selectively remove from the public attributes so that for any subset of the public attributes, every row in the record, and you could think of this like a regression problem where you have your data X, and these are the public, and these are the private. Okay, and you often want to build like a regression problem, say from the age, gender, maybe kind of ethnic background or other family traits to build a regression function from the public, maybe with some of the private to predict other of the private. Will they develop cancer, you know, if they have these sort of traits, right? I'm oversimplifying what people do for health, like health research, but kind of, and you want to build say a regression or a classification function on these to predict something here. And so you would try and think of, say, well, this attribute is too revealing, right? So if you actually have the GPS location of someone, so you're kind of, I'm working on a project where we're kind of working with a group of people and we're giving them a smartphone and tracking their movement, and we can track their GPS location. Well, the GPS location kind of can really identify where someone lives to that resolution, or if even if it's a fairly sparse thing, if where they live and where they work can pretty often zero in pretty specifically who the individual is. So I would maybe block this out. And maybe the zip code will map some number of people to the same location. Was a zip code maybe about 10,000 people inside the zip code, maybe, right? So if I just have zip code and I have age and gender, maybe I can argue that I shouldn't be able to identify an individual just based on those three traits. But if I add some other ones, or there's someone who's a very specific age, maybe someone is 102 years old. There aren't that many people 102 years old, so I can identify who them in. I need to black out some other kind of information because that would identify this person. Okay, so every row looks exactly like at least k other rows. Okay, so this was k-anonymity, and this does not solve the problem. Okay, so people started releasing data sets like this, and then okay, so this still leaked some information that was not so desired. It is because of the public-private split. I want to release this. I always want to release the private data, but the public data has been like anonymized. What could possibly happen? All right, let's look at, for instance, let's say these rows, let's say k is equal to 4, and there are the 4 rows. Okay, and let's say that there's some trait here that is interesting, and let's say that there's there's some trait here that there's a 1 in this case, meaning it's true, or maybe there's a true for if they have cancer, right? So there's some column, right, that I'm particularly interested in here. There's this have cancer column. And so there are 4 different people who have rows that have the same public profile, okay? But because I can't know which one it is, but what if that trait, the private trait that was released, is for all 4 of these people, they all have cancer. So I don't know which one of the four traits, the governor of Massachusetts is, but I know each one of those four people all have the same private sort of characteristic. They all have cancer. So I know that whoever these row is, they have this cancer, this private trait that does not want to be revealed. Or they all search for so Britney Spears over and over again, so something like that. Okay, so this did not totally solve the issue either. There were some kind of alternative definitions proposed. So the kind of the first alternative that really took off, diversity, L diversity. This was k-anonymity plus, okay. So each group had the private attributes had diverse values. Okay, so it couldn't be they all had cancer. So I would not be allowed to do this, where these four individuals, I didn't know who was who, but they all had to have, but I couldn't have them all have cancer. I would need to remove more characteristics so that there was some people without cancer who are also in that set I could identify. Okay, but this didn't quite solve everything either. The issue would be, well, what if all in the group had either cancer or diabetes? Okay, so I don't know what ailment they had that they were trying to do, but I know that they had one of two things. So I know that they had some reason. So if I'm now an insurance company and maybe I could look at pre-existing, conditions, or maybe not an insurance company, but I was interviewing someone for a job and I'm like, okay, this person has a low low life expectancy, or for some reason or another, so I don't want to hire them from this information that was leaked online. And I don't know what the reason was, but there was some reason to indicate that they had a low life expectancy from these private traits. Okay, and so after this, there was another version called T closeness. Okay, which was L diversity plus, plus you had to have that the private traits were close, so in distribution to kind of all data. Okay, so that in the distribution, if I looked at the fraction of people who had cancer, the fraction of people who had diabetes, that needed to, inside every subgroup, that needed to match kind of the general statistics of the population. It couldn't be exactly the same, but it had to be sufficiently close. So I couldn't say, well, I've identified them in a subgroup that had some certain kind of unhealthy trait. Okay, and so this was proposed. But now every block of data that looks identical kind of has traits similar to the general population. What kind of actual conclusions can I draw? Okay, and so I think this T closeness paper has thousands of citations, but it's probably removing too much information to draw actual inferences from the data. Okay, this is the idea of what information should we remove or hide from the release so that we could not draw inferences from groups. And so making fun of my bed. So So, and it's probably removing too much information to do something interesting. All right, so this is not the end of the story. This is kind of the end of this approach, except it's in the world of computer science, data science, academics. These sort of approaches are not really pursued anymore. But this family of approaches based on k-anonymity still seems to be pretty widely used with medical data releases. So I've talked to people in the health sector who've released some data sets, and they will do something of this form, and it has these limitations. You can still sometimes draw inferences and identify to a group people and draw some inferences from the group they've found directly from the data. That is in there. It's kind of susceptible to these, and it's susceptible to this kind of advanced kind of like machine learning attacks as well. You can say, well, based on the categories I have, I can actually often draw a pretty, with some confidence, prediction about, what sort of traits like an individual has, right? These approaches I'm not going to advocate, but these approaches are often what is used. They will kind of group people together into a spatial region and maybe release all the data, but only release the information about them is just what region they live on, like the map. And they'll build these census blocks or zip codes and say, I'll release statistics aggregated by, or all the statistics by zip code, but not give any other information about the individuals, right? And then you can look up aggregate from like census or a day, aggregate information about the demographics. And this sort of information is susceptible to these sorts of attacks, and usually they don't do this one, because then this would kind of destroy too much information where you're not going to be able to draw a lot of useful inferences from it. Okay, so I eventually want to get onto another method. Before I do that, I'm going to go back to another story. Okay, so very influential story, and this really marked the end from the tech sector's kind of when they stopped releasing sort of data. So who's heard of the Netflix challenge or the Netflix prize? Okay, right. So this was an enormously influential thing that like Netflix did. I mean, Netflix was influential in other ways, but from a data science perspective, this is the most influential thing they did. Around 2016, so Netflix, many of you are probably pretty young, you may not know this, but Netflix used to work by, you requested a movie, they mailed you a DVD, you would watch the movie on your DVD player, you know what that is, and then you would send the DVD back, and it came in like a little envelope, and you would you could mark on the envelope that you sent back, did you like the movie or not? Okay, so they were getting a bunch of ratings, and they were using these to recommend. You'd have a profile. The internet existed back then. Okay, it's not that old, but you go on your profile and you could see what you had rated, and then they would recommend other movies to you for the next one for them to send you in the mail. So in 2006, they wanted to build better recommendations for their users, right? They're like, Blockbuster was the other option. They just put movies on shelves and let people pick them up. They didn't really keep track of any sort of data like this at all. So Netflix, we're going to not only have a bigger library that you can get in the mail, not have to go to the Blockbuster, but we're going to do better with the data. And so it had a bunch of information from this data set, and they published this online. Okay, and they said there's a couple of 3 data sets. The first one has a user ID. It had a movie, the date that they graded the movie, the date that they watched it, and then the grade, like 1 through 5, where I think 5 was the best. Okay, and then there was another set that they also released, which had also user ID, which kind of aligned with this category, the ID of the movie, and then the date of the grade, and they wanted to predict what grade would they give, right? So the grade was, I think, 1, 2, 3, 4, 5, and they say, what are other movies that they would likely watch and have a high value for? Okay, and then they wanted to be able to predict this grade on this data set 2, and they're worried about overfitting, so they kept privately a 3rd data set that looked basically the same, and they would allow people to evaluate their grades, their predictions on the 3rd data set. And so every team who was participating in this could send in a model, an algorithm, a classifier or regression that would build a prediction, and they would run it on data set D3 and tell them back like how well they did. Okay, and I think and so this was the setup. That way, they tried to prevent overfitting by kind of just by looking at data set D2 too much. Okay, and so they announced if certain improvement over Netflix's algorithm, they said, here's how well we do on data set D3. If you can improve that by 10%, I think we'll give you $1 million. Okay, and so $1 million isn't that big, but it was also a really cool data set, and this really, a lot of people worked on this, like an enormous number of research groups, hundreds of research groups were working on this, and you know, there were some teams who basically worked almost full time in you know, just trying to win this prize. It became very prestigious, more than $1 million. The amount of man hours, person hours that was spent on this would have cost probably like $100 million in terms of the labor on kind of the individuals that they got out of this. Okay, and this led to an enormous amount of cool research, a bunch of methods for dealing with missing data, for recommendation systems, really doing kind of things like boosting, where you took a bunch of different algorithms and combined them together. This really came to be out of this sort of research. Okay, that's kind of extremely influential in shaping how we build some recommendation systems. Okay, and so, but at the end there were like a number of teams, and they kept joining together, but each team could only submit 1 query a day, so they waited to the end so they could jointly submit more queries, and then they combined together and boosted all their algorithms. So very cool stuff. Okay, at the same time, there's also like IMDB, and there are a bunch of people who watched a lot of movies on Netflix. They also, same set of those people, also on IMDB, you can have profiles apparently and rate your movies. This is not how I use IMDB, but really like movie fanatics would do this to learn about which exotic movie to watch. But they also have some user ID, and a lot of those people where you could identify them from their user ID on IMDb. And so, but a little after 2006, this was a very famous data set. Some researchers said, well, we can find people who rated similar movies based on the timestamp and the movie in Netflix and like IMDb, and we're quite confident we've identified something like a third to half of the data in the Netflix challenge. Okay, and it could be some people rented some movies on Netflix that they didn't want on their public profile, like IMDb, and so this was kind of some people were very excited about the techniques, but some people who were in the data set were not happy about this. right? They may have been watching embarrassing movies on Netflix and not rate them on IMDb. There was a class action lawsuit filed by people whose data was in Netflix and was released, apparently maybe without their consent, maybe they clicked the checkbox someplace agreeing to it. And so it was later dropped, but this became a big deal. There was going to be a sequel of this with an even bigger, more interesting data set. Netflix was so excited about this. A lot of tech companies were. This was a way to generate a lot of free research on their data. They're going to release this in 2010. I remember anticipating this data set. But they decided not to do it because of the privacy concerns, because of like the lawsuit. And this was basically the end of when these big tech companies would release all this data. Okay. And so now they keep it very, very private. You can do it internally, and they're much more cautious about this. Okay. So this kind of, yeah, so that's why you can find a bunch of data sets online, but around 2008 or 9, they stopped being new ones. It's exactly because of this. There's still some cases, like up until at least a few years ago, Twitter X would have this nice API where you could pull a lot of data from it. I think they stopped that for other reasons. Now a lot of the large language models have kind of memorized a lot of information. And so how to deal with the privacy kind of issues with what data they have gathered, whether it was legal or not, is now becoming an issue. And so, all right, well, we're not sure. I don't think the community knows how to deal with this yet. There are a bunch of proposals about how to present privacy. Some of this is copyright based, right? So a lot of, I think the copyright, so like a lot of these image generation methods, if they generate a picture of a Bugs Bunny, I think Bugs Bunny is still under copyright by like Warner Brothers. They have it in their training data set, but they can't generate it. So they'll build a classifier, and before it's done generating, or before they display it, they will say, oops, so I can't do that, right? So they do this for copyright data, but there's whole pieces of text that they've memorized as well. And if you're clever, you can get to extract a textbook that should be under copyright, because they don't care so much about that because they haven't been ready to sue. Yeah, okay, great. So kind of coming out of this, there was this technique, and this has started around 2006, called differential privacy. Well, it's more of a concept, a definition, than actually a technique. There's big kind of algorithmic questions of what is the right technique to achieve differential privacy. Okay, so with the k-anonymity, there are kind of these definitions that I want to not be able to identify an individual up to a certain group on the public data. But there were kind of these attacks that you could make on the data, and it was hard to kind of prevent against these attacks.